time to answer the big question. Why statistics? Well, if business intelligence is about using data to make smart decisions, then statistics is about evaluating those decisions under uncertain circumstances. And the truth is that, by that definition, we don't always need to use statistics in order to use data to make smart decisions. So when do you need statistics? Well, there are two conditions that need to be met. Number one, you don't have all the data that you're interested in, which means that you can only analyze some of the data that you need to make your decision. In other words, there's uncertainty involved. Think about it. If you have all the information you need, then you don't need to run any fancy hypotheses tests or regression analyses. Just take a good look at it using Excel or any other BI tool, and you'll get your answer. And condition number two, the decision that you're making is important, which means that you don't want to make the wrong one on a whim based on your limited data. In other words, there's something specific to evaluate. And it's under these conditions that statistics really does shine as a decision-making tool when used properly. But it is also important to realize that not every scenario is like this, and that sometimes it's okay not to waste time on statistics. Okay, so if the purpose of descriptive statistics is to summarize the characteristics of a variable, then we need to discuss the different types of variables. Now, you might run into different breakdowns in other stats classes or textbooks, but ultimately there are two main types of variables in a dataset. You've got numerical variables and you've got categorical variables. Now, numerical variables represent numbers that are meant to be aggregated. So these are things that you add up or you calculate averages for. And categorical variables represent groups or categories that can be used to cut or filter numerical variables. And we'll see an example of that in a few seconds. For now, let's take a look at the variables that we have in our project, which are really the columns in our dataset. Now, I want you to pause the video and quickly think about which of these variables are numeric and which are categorical. I'll wait. All right, let's break this down. As you might have guessed, the numerical variables are all of these in the left with the numbers, right? And the categorical variables are all the others. Now, we do have this curious exception in the student ID, because even though these are technically numbers, it is still a categorical variable because these numbers aren't meant to be aggregated. The sum or the average of the student IDs doesn't really mean anything. They're ultimately just numerical labels that are used to identify or filter each student. And another way to think about it is in terms of a possible question that you could have about the data. Something like, what's the mean annual salary by work experience? Well, that clearly shows that we're aggregating the numerical variable, which is the annual salary, and we're filtering it by work experience, which is categorical. So again, that's your quick intro into the types of variables and how we're going to be using each type going forward. All right, time for the inevitable vocabulary lesson, because whether we like it or not, statistics does have some key terms that are important to know right off the bat since you're going to see them referenced all across the course. So let's talk about populations and samples. Now, a population contains all the data that you're interested in to make your decision. In other words, it's the data that you wish you had, but are most likely unable to get. And any figure that summarizes a population is called a parameter. Now, to put this into context with an example, imagine that you own a pizza place and you need to know how many dough balls to make every day. Well, in that scenario, the data that you'd be interested in is the number of pizza sales that you'll have every single day. That's your population. And then the parameter could be something like the average number of pizza sales per day. But here's the problem. Do you know how many pizzas you're going to sell every day? Of course not. I mean, how can you if the day hasn't even happened yet? Which brings us to the next term. A sample contains some of the data from that population. In other words, it's the data that you do have, which should ideally represent the population, but that's a whole other conversation outside the scope of this course. And any figure that summarizes a sample is called a statistic. So if we go back to our pizza example, then the number of pizzas that we've sold every day in the past could be our sample, and the statistic would be the average number of pizzas that we've sold every day. And here's the important part. Statistics lets you make reasonable estimates about population parameters using sample statistics. In other words, we can use statistics to look beyond the past sales data that we have and make educated guesses about the future sales data that we don't have about the whole population. And before this starts to feel like magic, I do want to call out that statistics can't create certainty out of uncertainty. All it does is provide the framework that helps you make controlled decisions under that uncertainty. Which is still pretty cool if you ask me.